Okay, this is the third video for assignment 48, and we're going to look at solving systems of equations by graphing. And then in the next video, we'll look at solving systems of equation by the substitution method, and then by the elimination method. In the final video or two, we'll look at solving systems of nonlinear equations. A little bit later on in assignment 51, you'll be introduced in techniques on how to solve systems of equations using matrices. Okay, so we're going to go ahead and look at how to solve a system of equations. I think we have three examples by graphing. So we have the system of equations, x plus y is equal to negative 1, and y equals 2x minus 1. What I'm going to do is I'm going to make sure that both of them are of the form y equals mx plus b, so then I can identify my slope and my y-intercept. It makes it easy to graph. So x plus y is equal to negative 1. Subtract x from both sides. We have y is equal to negative x minus 1. The slope is the coefficient on the x, which is negative 1. We can write that as negative 1 over 1. So that's going to be down 1 and right 1. The y-intercept is going to be 0, negative 1. So we're going to go ahead and graph that. So we're going to start at our y-intercept at negative 1, and then from that, we're just going to go down 1 and right 1 a whole bunch of times. Now you can do the exact opposite, and you can get some more points by going up 1 and left 1. Okay. Once you've done that, you got a whole bunch of dots. Connect your dots. Use a straight edge, student ID. That works. And then draw your arrows, because this line goes on indefinitely in both directions, and label it. This is x plus y equals negative 1. Okay. And that's it. Now the second line here, y equals 2x minus 1, that's already in y equals mx plus b form. Here the slope is going to be 2. Now we can write that as a fraction as 2 over 1. So you're going to go up 2 and right 1. This one also happens to have the same y-intercept of 0 and negative 1. From 0 and negative 1, you're going to go up 2 and right 1, up 2 and right 1, and you keep going. Okay, now if you want to go the opposite, you would go down 2 and left 1, down 2 and left 1, and that'll give you some more points on the graph. Once you've done that, connect your points. Okay, and we'll label our graph y equals 2x minus 1. Now when we're solving a system of equations by graphing, we're looking at where do they intersect, where do they cross each other. And this happens at the point 0, negative 1. And that is our solution. And from the previous video, if you do have an intersection at one point, we call that an independent solution, or independent system, I think is what we called it, an independent system. So you can, the word independent, maybe think two independent lines. Okay? All right, let's try another one. Let's say we have x plus y is equal to 4, and 2x plus 2y is equal to 0. I'm going to take the first equation, and we're going to solve it for y to get it in mx plus b form. So y equals negative x plus 4, so we subtracted x from both sides. Okay, your slope is going to be equal to negative 1, which is negative 1 over 1, so you're going to go down 1 and right 1. The y-intercept is going to be 0, 4. So we're going to go all the way up to 4, and that's going to be our first point. And then from there, we're just going to go down 1, right 1, down 1, right 1. We'll get a whole bunch of points, okay? And if you want to go the opposite direction, go up 1, left 1, up 1, left 1. Get a couple more points, okay? Connect your dots to your straight edge and label your line. Let's go ahead and graph the second line. So we're going to look at 2x plus 2y is equal to 0, and we want to solve this for y. So the first thing we're going to do is we're going to subtract 2x from both sides. When we've done that, we have 2y is equal to negative 2x. We're going to divide both sides by 2, and we get y is equal to negative x. The slope is the same as the first line. It's negative 1, which can be rewritten as negative 1 over 1, so we know that it's down 1 and right 1. Okay. Notice that there's nothing else, it's just y equals negative x. So, negative x plus 0. So, the y-intercept is in fact the origin. Okay. Notice that they do have the same slopes. That's what we'd call parallel lines. Okay, so we'll start at the origin and down one, right one. Just a whole bunch of points. Okay, and then we'll go ahead and connect them and label our line. And when we're solving a system of equations by graphing, we're looking at where do the two lines intersect each other. Now they're parallel lines, so and they're not touching each other. They never are going to touch each other, so or intersect each other. So this is a no solution, no intersection, and I'll mention we have parallel lines. And this is what we would call an inconsistent system. There's no solution for it. All right, let's look at one more. We're going to graph y equals 1/2 x plus 1 and 2y minus x is equal to 2. The first equation, y equals 1/2 x plus 1, that's already in mx plus b form. The slope is equal to 1/2. So you're going to go up 1 and right 1. Sorry, right 2, pardon me. And then your y-intercept is going to be 0, 1. So let's go ahead and graph it. So 0, 1 is our y-intercept. And we're going to go up 1, right 2, up 1, right 2. Okay. Now you can also go down 1 and left 2. So do the opposite, down 1 and left 2, and get a couple more points. Connect your dots and label your line. Okay, so 1 down. Let's go ahead and graph the other line. 2y minus x is equal to 2. We're going to solve for y, so it's in y equals mx plus b. So we're going to add x to both sides. Okay, and then we're going to divide by 2. So then 2y divided by 2 is y. Okay, and then x divided by 2. Dividing by 2 is the same thing as 1/2 times. So half of x is the same as x divided by 2. And then 2 divided by 2 is 1. Okay, so this in fact has the same slope as the previous one, so 1/2. So you're going to go up 1 and right 1. And the y-intercept is the same also. Okay, so if you have the same slope, same y-intercept, same line. Okay, so we got the exact same line. And if the lines are the same, this means that you're going to have infinite solutions. And so we can get fancy and say it's the set, so we use a little squiggly bracket, of all points x comma y, and then you can use either one of the equations, y equals 1/2 x plus 1, or 2y minus x is equal to 2. Doesn't matter which one. I'm going to say 2y minus x is equal to 2. So it's the set of all xy such that 2y minus x equals 2. So 2y minus x equals 2, that's going to be all the points on the line, so we're saying we want all the points that are on the line. And we would say this is an infinite solutions, and then we'd also say that we have a dependent solution. I think we also probably said, instead of solution, I think we might have said system. So we're talking about a system of equations. Okay, system, not systems. Okay, all right, so that's the 3 different cases that you will run into when you're solving a system of equations by graphing. They'll intersect at one place. You'll have one solution, independent system. You will have parallel lines that don't cross or intersect, so that's going to be a no solution and a inconsistent system. And then finally, the 2 lines are actually the same. You have infinite solutions, and we call that a dependent solution. A dependent system, pardon me. Alrighty. In the next video, we will be looking at the substitution method for solving systems of equations. So we'll see you on the next one.